Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the extended product rule. So let's start with part A. So in part A, we have to write an expression for prime of h at x if h at x is equal to p at x times q at x times r at x. So the expression for extended product rule is so prime of h at x equals prime of p at x, which is the derivative of the first function, times the second function times the third function, plus the first function, which is p at x, times the derivative of the second function, so prime of q at x, times the third function, which is r at x, plus the first function p at x times the second function q at x times the derivative of the third function, so prime of r at x. So we are able to use the extended product rule for this function h at x because h at x is made up of three functions being multiplied. P at x is the first one, q at x is the second one, and r at x is the third function. Now we can use this expression to answer part B. So in part B, we have to find that if h at x is equal to x times 2x plus 7 exponent 4 times x minus 1 square, find prime of h at negative 3. So the first step is to find the derivative of h at x. Now this function h at x is made up of three functions being multiplied. The first one is x, the second one is 2x plus 7 exponent 4, and the third one is x minus 1 exponent 2. So we can consider this first function x as p at x, the second function as q at x. So it will become easy to reference these three functions. And then the third function as r at x. Now we can use the expression that we got in part A, but for that we'll need the expressions for prime of p at x, prime of q at x, and prime of r at x. So first, let's find the derivative of these three functions. So p at x, we said, is equal to x, the first function in the function h at x. So prime of p at x is equal to 1. So we'll use this value for prime of p at x in the expression for prime of h at x. Now let's analyze the middle function. So q at x is equal to 2x plus 7 exponent 4. So we can find the derivative of this function. So prime of q at x. So we'll have to use the chain rule because this function has an inner function 2x plus 7 and the outer function, which is the exponential function with exponent 4. So for the derivative, we'll start with the derivative of the outer function, and for that we'll use the power rule. So we'll move the exponent to the front, so 4 times 2x plus 7, and we'll subtract 1 from 4 times the derivative of the inner function. The inner function is 2x plus 7, so the derivative of that will be 2 plus 0. So 2 is the coefficient, so it stays as it is. The derivative of x is 1 and 7 is a constant term, so the derivative of 7 is 0. Now we can simplify this expression. So prime of q at x is equal to, so in the parentheses 2 plus 0 is just 2 and we can multiply that by 4, so we get 8 times 2x plus 7 exponent 3. So this is the value of prime of q at x. Now similarly, we can analyze the third function in h at x, which is r at x. So r at x we said is equal to x minus 1 square. Now we can find the derivative of the function. So prime of r at x equals, so we'll use the chain rule again. So the inner function is x minus 1. The outer function is the exponential function with exponent 2. So the first step is to find the derivative of the outer function. So we'll move the 2 to the front times x minus 1 exponent 2 minus 1 times the derivative of the inner function x minus 1, which will be 1 minus 0. Now we can simplify this expression. So prime of r at x, so 1 minus 0 is 1. So multiplication by 1 doesn't change anything. So we just get 2x minus 1, and the exponent is 1, but we don't write 1 as an exponent. So these are the expressions we can use in the prime of h at x expression to find the prime of h at negative 3. So first we'll write the expression for prime of h at x. So that will be the prime of p at x. So we got 1 times qx, the second function, which is 2x plus 7 exponent 4 times the third function r at x, which is x minus 1 squared, plus now the first function, which is x, times the derivative of the second function, so prime of q at x times 8 times 2x plus 7 cube times the third function r at x, which is x minus 1 squared. Now plus the first function x times the second function, which is 2x plus 7 exponent 4 times the derivative of the third function, so which we got as 2 times x minus 1. So this is the expression for prime of h at x. Now since we have to find the prime of h at negative 3, in the next step we'll sub in x as negative 3. So in the first part, so multiplication by 1 won't change anything, so the 1 goes away, so we get 2 times negative 3 plus 7 exponent 4 times negative 3 minus 1 square. Then the second part plus negative 3 times 8 times 2 times negative 3 plus 7 and then cube times negative 3 minus 1 square. Now the third part plus a negative 3 times 2 times negative 3 plus 7 exponent 4 times 2 times negative 3 minus 1. Now we have to evaluate this expression. So we'll start by simplifying the term in the parentheses. So 2 times negative 3 is negative 6 and negative 6 plus 7 is 1. So we get 1 exponent 4 times negative 1 minus negative 3 minus 1 is negative 4 square, then plus, so negative 3 times 8 is equal to negative 24, and then parentheses, so 2 times negative 3 is negative 6 and negative 6 plus 7 is 1 cube, then times negative 3 minus 1 is negative 4, then square. Now in the last part, so negative 3 times 2 is negative 6, and negative 3 minus 1 is negative 4. So negative 6 times negative 4 is 24. So we get plus 24, and then in the parentheses we get 2 times negative 3, which is negative 6, and negative 6 plus 7 is 1, exponent 4. Now we can simplify it further. So prime of h at negative 3 equals, so 1 exponent 4 is just 1. So multiplication by 1 won't change anything. And negative 4 square is equal to positive 16. Now in the next part, so 1 cube is just 1. So it becomes negative 24 times, and negative 4 square is equal to positive 16. Now in the third part, so 1 exponent 4 is just 1, so it will just be positive 24. Now we can simplify this expression. So we get prime of h at 3 equals to 16, and now we have to do negative 24 times 16, which is equal to negative 384 plus 24. Now we can combine these three terms to get our final answer. So we do 16 minus 384 plus 24. So I got negative 344. So this should be the final answer for the prime of h at negative 3 for this given function h at x. So these are the steps you have to keep in mind to solve a problem like this one. So you can see that the expression becomes very big when we use extended product rule for a function in which there are three functions being multiplied. So you have to be very careful with the calculations. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.